Hello there. We're going to do 8.4. This one is on testing differences between proportions, and it's going to use the z-test. This one sticks out because there's no mention of standard deviations or means. It's all about proportions, and there'll be two of them that you're comparing. The formula looks a little crazy, and it is. It's got formulas within formulas. Just like before, you can cross that one out because that always equals 0. Makes it a little simpler. But let's look at this one and see how it goes. So we have magnetic insoles to treat heel pain. And then we have 54 subjects wore the insoles and 50 wore non-magnetic ones. And they're asked if they felt better. Can you support the claim, or let's test the claim that there is a difference in the proportion? So right off the bat, I can jot down my HOHA on that fact. Is there a difference in the proportions? That would be, does P1 differ from P2? That's the claim. And then, of course, H sub 0 would be equal. So notice we're using P's for proportions. Keyword there is proportion. And away we go. Got a two-tailed test. Now in that formula, which is going to be the next thing we do, there's lots of X's and N's and P's and P hats and P bars. Okay, so let's break that down. First off, P hat sub 1 is an X sub 1 divided by N sub 1. Has a little formula for itself. The proportion of people who felt better when they wore magnetic insoles. So under magnetic, 20 people said yes, they felt better out of a total of 54 subjects. Okay. So that's about 0.370. Okay. Sub 2 is the non-magnetics, 18 out of 41. 0.439. Okay, so we'll need those because those appear in the top of the formula. Next, you notice in the bottom of that formula, we've got P bar, and that has a little formula for itself. Also Q bar. Q, as we've done all semester, is 1 minus P. Okay, so for P bar, we're going to take the X's and add them together. So that's the 20 plus the 18, the top two from the P hats, and then on the bottom is the N's added together. Okay, so this is 38 divided by 95, 0.4. Exactly. All right, now we're ready to find that z-score. And then once you get that z, everything will flow like we've seen. Okay, so z, here we go. We're taking P1 minus P2, P hat 1, P hat 2, over, now we've got big square root. P bar, 0.4, and then Q bar, 0.6, and then we got in the formula a 1 over n plus 1 over n. By the way, that 0.6 is 1 minus P bar, so it's 1 minus 0.4 is 0.6. And then we have a 1 over 54 plus 1 over 41. Okay, let's calculate this and see what we got. And I always encourage you to try these on your own as well, just to make sure your calculator is working, getting it entered in right. But this is about negative 0.68. Okay. Okay. At this point now, you could do p-value or critical value. It's the same as all of the other p-values and critical values we've done for the z distribution. So I'll just do critical value, seems to be more common in these sections. Critical value, two-tailed test, alpha 1%. So you're gonna go back up to that table. Let's just scroll up there. Where did it go? There it is, sorry. 1%, 2, plus or minus 2.576. So plus or minus 2.576. Okay, how does that work? I can draw it. Get your rejection regions going. And that z-score is not in there, right? So this is a fail to reject h sub 0, as you guessed it. And then we combine it. So h sub a was the claim, and we could not reject h sub o. So there is insufficient evidence to support this claim. Okay, insufficient because we failed to reject, support because HA was the claim. And that's that one. If you had to find the p-value, you can use the standard normal table to find that p-value, or StatCrunch. Okay. Let's try another one. On this one, let's try doing this one using StatCrunch. Okay. So we've got Nevada versus California. Maybe I'll just outline what these values are. In a survey of 340 Nevada drivers, 289 wear seatbelts. So X1 is the 289, X is the smaller one, N is the bigger one. So sub 1s are Nevada. In California, X1 is 282. Hey, sorry, X2, and then 2 is 300. 5% level of significance. Can we support this claim? Okay, let's see the StatCrunch feature for this one. Well, let's just get the HO and HA down. Can you support the claim that the proportion of drivers Nevada less than California? P Nevada less than P California is the claim. So this is a left-tailed test. That would be the H sub 0. Okay, we'll need that inequality when we do StatCrunch. Okay, so let me jump to StatCrunch. So you're just going to open a blank StatCrunch page. And this feature is under Stat Proportion Stats to Sample with Summary. Okay, proportion to summary. And these should all be in whole numbers here, right, which were given. So they're all the X1s and the N1s, right? So my sample number 1 was 289 out of 340. Sample 2, 282 out of 300. And then the hypothesis, HA inequality was a greater than. So I got to worry about and just leave that 0. All of chapter 8, you're leaving this 0. Okay, there's the setup. That's it. Compute it. It's going to give you your z-stat and your p-value. Oops, I think I had that. Oops, let's see. My bad, I had that HA wrong. Indicator of that is a p-value of 0.999 usually means you have the inequality the wrong way. So looking back at my handout, it's the HA is a less than. You probably caught that while I was doing it. But I caught it. All right, now we're good. Okay, there, that's better. So still got the same Z, but the p-value is 0.0001. Okay. And now we go back to our handout and we complete the problem. Using that p-value. So with the p-value of so small, it's definitely less than the alpha of 5%. So anytime the p-value is small, it's reject H sub 0. And if we're rejecting H sub 0, we're going to support HA. Right? There is sufficient evidence to support the claim. So you always use the word sufficient or enough when you're rejecting H sub 0. And if HA is the claim, you're going to use the word support. If HO was the claim, you'd use the word reject. Okay, and that's it. Those are the two examples for now. One other thing, you may, in a problem here, was nice because you were given the x's and the n's. You may be given the p hat, right? So, you know, if it said like 38% of the drivers wore seatbelts out of 340, you're gonna have to find the x on your own to put it into the StatCrunch, right? So if it gives it as a percentage, for example, just 38%, and then it gives you the n is like 400 or whatever, then the x, the value you're gonna have to put in the calculator for number of successes, would be 0.38 times 400. And then whatever that is, you put it in the number of successes in StatCrunch. So that's one thing that could happen in your homework. Okay, that's it for now. Hope all is well with you. I'll talk to you later.